So I'm just going to go ahead and start. Oh, perfect. Random party process.
We're working on the problem of storing large volumes of digital data. The issue we're dealing with is that we're producing a lot of data and current storage technologies cannot keep up with it.
We are using DNA as a storage medium for digital data. We are using synthetic DNA for data storage, so that means that we're storing zeros and ones into DNA molecules. And the zeros and ones can be images, video, anything, any data you want. And the reason we're doing that is because DNA is very dense. You can put a lot of data in a small volume. To give you an idea, the whole accessible internet is estimated to be about 700 exabytes, and that would fit in the size of a shoebox. The other reason is DNA is very durable. In the right conditions, DNA can last for thousands of years compared to other storage technologies that last on the order of decades. And finally, DNA does not get obsolete. DNA will always be relevant. We're always going to have reasons to read DNA.
DNA is made up of various sequences of 4 types of molecules: A, C, G, and T. The first step in the process is to turn the data we want to store into sequences of those 4 molecules, along with the markers that identify where data belongs in the original sequence. These sequences are then synthesized into actual DNA. When we receive the DNA, many files may come together in a single pool. We make a number of checks and then use a process called polymerase chain reaction, or PCR, to select only the sequences of the files we want to read. The PCR process will multiply only the sequences of those files. The last step is to read those sequences and turn them back into data.
So last year, we stored hundreds of kilobytes of data in DNA and fully recovered that. This year, we're working with hundreds of megabytes of data, which means 1,000 times more DNA.
In building the world record, we've worked with Twist Bioscience to synthesize 200 megabytes of data, which is well beyond anything that's been synthesized to date. Along with the collaboration with the University of Washington, we've demonstrated that we're able to recover data built out of 1.5 billion nucleotides.
The growth that we're experiencing in our global data centers is truly astounding. It's a challenge not only in creating new technologies to deal with it, but in actually inventing the new science to form a foundation for the future. DNA storage gives us that new foundation, and this is exactly the kind of problem that Microsoft Research was built to solve.